Okay, we have 2 more topics left for today. Now we'll talk about backups. It's an overview, but we'll see basic concepts. We'll talk about 2 things, about logical backup and about physical backup. By logical backup, I mean tools that can output commands, SQL commands, that recreate your database or your cluster or some different objects. So it's basically just SQL commands. What is the advantage of this method? First of all, you can make a copy of some object from some table or a single database from your cluster. You can use this copy to restore your objects in another major release of Postgres. For example, you can backup your table from Postgres 9.6 and restore it in Postgres 10, no problem. Or even you can use this file to create these objects in another database. Also, you can restore your database on other architecture. You don't depend on type of processor of 32 or 64-bit systems and so on, because you just need to execute SQL commands and you can do it on any platform you want. But for large databases, this is a very slow process because you need to create a lot of commands, you need to recreate indexes and so on. So it's good for making copies of some objects, but it's not good for large databases. Let's see how it works. First of all, we have a copy command. A copy command can output all your table or result or some SQL query to a file or to a console or even to some other program. It outputs rows in some format. Format is configurable. You can use comma separated fields or some other formats. And then you can use the same command to read this data and to put it into a table. Table is not truncated, so it just adds these rows to all existing data. And we have 2 types of this command. Server-side command, it's basically an SQL command copy. It's Postgres extension of SQL. And we have client-side command, \copy in PSQL. The difference is the following. When you run SQL command copy, your file to which you write your data or from which you read your data must reside on your server, so that server can access this file. And when you use PSQL copy command, you do it from your client, and so files must reside on your client's computer. And data is transferred over network to server and back. Also, we have pgDump utility. pgDump dumps a database or some objects from a database. It can output plain text format, SQL commands, or it can create file in special internal format with table of contents in it. So if you output SQL commands, you just you can execute them using PSQL, and if you output your dump in special format, you use pgRestore utility, which can convert this internal format into SQL commands and then execute them as usual. pgDump supports parallel execution. You can dump several objects in parallel, which can speed up making a backup. pgDump works only on database basis. So all global objects of your cluster, such as roles and table spaces, you have to backup separately. So you can make dump of your database, and to restore this database on another server, you have to create your roles, you have to create table spaces in advance, and then you can restore your backup.
How consistent is the pgDump?
pgDump always output consistent information.
Across all the databases for a specific timestamp?
Yes. It uses snapshot as usual SQL command, so it output consistent information.
So if I start pgDump now, and during the process, tables are changing.
Yeah, it's possible.
While the tables will be dumped, what will
tables will be dumped at the state that was at the beginning of pgDump, yes. And even if you use parallel workers, they all see the same consistent picture, so your backups are always consistent, of course. And we have pgDump all utility, which dumps all cluster with all its database and all roles and table spaces and so on. So pgDump all you can use to dump all your cluster. pgDump all doesn't support parallel execution. It always produces simple plain text SQL commands, but you can instruct pgDump all to dump only global objects and then run pgDump for each of your databases in parallel to make this process more to speed up this process. Okay, and the most interesting thing is physical backup. Physical backup is based on recovery mechanism of PostgreSQL. You can copy your data files, so you can get binary copy of your system. But while you copy this data, the system may change, so you can get inconsistent information in your files. And that's why you need whole files to restore consistency after that. It's the same mechanism as Postgres uses for recovery from failure. This method has good performance. It is much faster than logical backup. It makes it possible to use point-in-time recovery, so you can restore your system not only at the moment when you created your backup, but on some more, on some other moment in time. But using physical backups, you must backup all your database cluster. You cannot make a copy of some databases, for example, because files in PostgreSQL are intermixed, and you cannot just copy some of these files. You must copy all information in your database cluster.
There's no incremental backup?
No incremental backup in standard Postgres. There are tools which can do it. A number of backup utilities, third-party utilities. For example, our company has ProBackup, which can do incremental copy on page level, and some other backup utilities also can do this. And because it is a physical copy of data, you can restore your database only on the same platform, only on the same major version of PostgreSQL. You cannot create a copy of your 9.6 Postgres and restore it on Postgres 10, for example. It is not possible. Also, it is not possible.
Not to upgrade?
Yeah. Systems must be binary compatible. So the same architecture, same platform, same major version of PostgreSQL only. There are cold backups and hot backups. What does it mean? Cold backup is a backup which you make when your server is shut it down. So it is not working. When you shut it down cleanly, you can copy data files, and you even don't need to have WAL files. You can just copy these files to some other place and then start up your Postgres, and it will work with your files with no problem. If your Postgres wasn't shut down cleanly, then you will need WAL files to restore consistency, just like after any crash. But all these WAL files will be contained in pgWAL directory, so you will copy them with all other data files anyway. The situation can appear when you use file systems which can make snapshots. For example, ZFS file system can make snapshots, so you can make snapshot and use it as your backup. And hot backups. Hot backups is most interesting, because hot backup you can do on running PostgreSQL. And this is the main method of doing backups in Postgres. You are copying files, and you need to have all WAL files from the moment when you start copying. And here is one tricky moment, because Postgres is doing checkpoints, and it can delete some WAL files. And if copying takes a lot of time, you have gigabytes, terabytes of data, Postgres can delete some WAL files, and you will not be able to restore from this copy. So you must somehow ensure that you have all WAL files from the very moment when you start copying your data. And Postgres provides support for this. First of all, let's look at standalone backup. Standalone backup contains both data and WAL files, so you don't need anything else. You can just start up your Postgres from this standalone backup. The simplest method of doing a standalone backup is using pg-based backup utility. pg-based backup utility connects to your server using special protocol which is named Replication protocol. It is used not only for replication but also for backups, so that's why it uses this protocol. Then it performs, excuse me, then it performs a checkpoint and switches to the next WAL file. And then it starts copying your data to the location you specified. After all data is copied, it again switches to next WAL segments, and it copies all WAL files between two switches to the backup copy.
What format? What is the format of the destination files?
Just files.
The same as in the source?
It has some different formats. In the simplest is just one-to-one files. It can use star to archive this, but it's just files. And this utility also uses replication protocol to get all WAL files necessary. So it is ensured that it will get all necessary files. So you can, how you can restore from this backup? You just copy your backup to location that you want, to a server that you want, and start up your Postgres, and it will restore consistency. It will rerun all WAL records from the start of copying data, and you will get working PostgreSQL instance. About replication protocol. Replication protocol allows you to manage backups and replication. For example, it can doesn't matter. There are some internal commands to manage this process, and it is possible to transfer data and WAL records by this protocol. And pg-based backup uses this protocol. When some utility connects with replication protocol to the server starts a special WAL sender process, which returns all necessary information to the client. WAL level parameter must be set to replica for this to work. And also you can use replication slot. Replication slot is a database object which remembers what WAL records it sent to a client. And the server will not delete WAL files which were not completely sent to a client, and client must confirm that it received these files. So slot is used to ensure that server will not delete necessary files. Here is some pictures. Here we have a database, primary server. Here is some data. These are WAL files. They consist of records and they are replaced. There is some workload, selects and sorts and so on, which generates new wall records and changes data in your database. And you have pgBase backup utility, which copies your data and wall records to some place that you specify.
The pgBase backup is working when you do replication?
No, it is utility for backups. You use this to make a copy of your system, but when you run this, when I run another Postgres instance as a replica, it will connect to main server using the same replication protocol, but pgBase backup you use only to make this copy. So after that you can copy this data to some location and run here another server. Next idea is the following. If we can restore from a standalone backup, we can continuously add new wall records to this backup when main server is, primary server is working. And this way we can restore our system not to the moment of creating our backup, but to any moment, to any point in time. It is named point in time recovery. You can set up continuous archiving for that, which transfers completed wall files to some archive, or you can use streaming archive, which writes stream of wall records to files. Continuous archiving is managed by PostgreSQL server itself. It means of some configuration. You can turn it on by archive mode on parameter. You must specify archive command. It's just a shell command, Unix command, which will copy already completed wall file to some archive that you want. PostgreSQL knows nothing about what archive you are using, so you can write any shell command. It may be cp just to copy files, or you can copy it over network to another server, anything you want. This command must return 0 with 0 status to inform PostgreSQL that it successfully copied your file to the archive. If not, Postgres will try to execute this command again and again until it gets 0 status. And it will not delete your wall file until it gets into archive. Okay, it looks like this. Here is our primary server, and archive command copy completed segments to the archive. So you have base backup, and you have archive of wall files, and you can just replay all these wall records to get to necessary point in time. Also, you can use streaming archive. There is utility pg receive wall. You can run this utility on say another server. This utility connects to primary server by replication protocol, gets the stream of wall records, and writes them into files in local files. So you can get streaming archive. In this case, you will get your wall records without significant delays. Continuous archiving copies completed segments, 16 megabytes. And this way you copy wall records at time when they appears. But this utility is you must run this utility by yourself. You must monitor this utility by yourself. When you switch to another server, you must shut down this utility and run it again with another parameters, so it's more complicated. Okay, here it looks like that. PG receive wall utility archive, and it connects to the primary server by replication protocol. Here you can see wall sender process, which sends wall records to this utility. So, how we can set up our backup? We must have wall archive. For example, continuous archiving, streaming archive. Then you can run PG-based backup utility, but in this case, you don't have to put wall files into your backup copy, because all archive records already are in wall archive. And to restore, you copy your base backup to the server that you want, and then you have to create a configuration file, recovery conf. This is a file which controls recovery process. In this file, you can specify some parameters. You specify where the server can get wall files from archive, and you specify your target point in time. And then you start your server. It sees that you created recovery conf file, and it uses it to get all necessary wall records from archive and restore up to the specified target point. For example, we have had continuous archiving. We have base copy. This is archive. And something happens to primary server. We can copy this data to some server, start up the instance. It will read wall segments from the archive one by one, and when it reaches recovery target point, it stops recovery and becomes new functional server. And if you have archive command configured, it will continue to put wall records in the same archive. Well, let's see it on practice. In this demonstration, we'll see how logical backup works and how physical backup works. Let's create a database, create a table in this database, and put some rows in the table. Here it is, 3 rows. And you can use copy command to make a copy of this table. Copy table name to stdout. It gives us contents of this table on our console. We can see that null values are represented differently from just empty strings. So Postgres understands that this is different things. And you can use the same command to read some data and put it into your table. Let's truncate the table and use copy from stdin, or you can use copy from some file. Here we enter all information, and we have this table restored. pgDump. Let's make a simple copy of our database. We use pgDump, we specify database, and also there are a lot of arguments that you can pass to this utility. For example, create will add create comments to this backup. So what we get here? Here we get some SQL commands to set parameters. Here we can see create database command. This command is created due to this key, create. And you can see that Postgres uses template 0. Do you remember that template 0 is a database which never changes? It is created during initialization of a cluster. Why Postgres uses it? Because in this backup you will get all your changes that you make in template 1 database. And if you will try to replay these changes on template 1, you can get some errors. So it is applied on top of template 0 database. We connect to the created database, again set parameters. Here we can see create table command, which recreates our table. And below we can see copy command, which just copies all information from stdin to our table. So these SQL commands recreate our database from scratch. This is how pgDump works. For example, we can restore some objects in another database. Let's create another database, and we can use the following command: pgDump. We specify that we want only one table in our backup, and then we pipe these SQL commands to PSQL, and PSQL is connected to another database. So we redirect SQL commands to another database, and we get this table in our second database. As you can see, we use beta server here. So we created this table on another server from backup. Okay. About physical backups. We must have wall level at least replica. Here it is. And we must set max wall senders to some value. Max wall senders limits number of wall sender processes. By default, now Postgres have 10 such processes, and this is enough for us. So it's okay. Also, we must have special records in pgDay file. In these records, we must use special keyword replication in place of database name. This means that we allow connection by replication protocol. And again, Postgres 10 and Postgres 11 have these permissions, so we can just use it and we have no need to change this file. Okay. We remove anything in data directory of our beta server with this rm command. And then we run pgBase backup. It will connect to our primary server, alpha, and our backup will be put into the directory of our beta server. So we will have backup in place of our beta server. We can look into this directory and you can see that it contains the same files as usually you will see in pgData directory. Besides, there are some files, for example, backup label. It means it contains some information when you made this backup and so on. We want to run this server on the same virtual machine, so we have to change port number because we cannot have two servers with the same port number. And with this command, we add port number to PostgreSQL autoconf file. And that's all. We can start our server now. Start beta server. We can connect to it. Here is our alpha. We can change data somewhere. And on our beta server, we have another copy of the same data. So it works as expected. Okay. Any questions?
Do you have some best practices for continuous backup? What to do, like once a day and then dump each week, or here's some insights.
It depends on your requirements to the reliability of your system. For example, you can make usually in production, so if you talk about best practices, you will not use pgBase backup. You will use some other tool. It uses the same principles, of course, but pgBase backup, for example, it doesn't remember which copy it makes, so you just run it, it creates backup copy and knows nothing about it. You must yourself remember when you make these copies. real backup utilities always have some catalog of backups, and they support incremental backups and so on. So you may decide that you want full backup each week and incremental backup each day, or you can come up with some other recovery politics, so it's up to you. PG-based backup is a standard tool. It uses replication protocol as any other backup tools, but it is rarely used in real life. In fact. Okay. Let's make a little break. And we have one more topic about replication.
Is there an audit in Postgres? Audit user or something like that? Auditing.
Auditing. There is an extension which is named PG Audit for this, but it's no internal auditing in Postgres.